Hi, I'm Dave Robinson, and welcome to another screencast. We'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, an amazing weekly data project in R run by the R for Data Science online learning community. And as usual, I'm screencasting this live, so I'm really excited that if you're here live, say hello and give some ask questions, give ideas for figures or analyses you're interested in seeing. It's really one of my favorite parts of these screencasts, doing them live, interacting with you as we analyze this data set together. So let's see what we have this week. All I know about is US broadband access, and all right, it looks like we're looking at the broadband gap. Broadband access was a problem for 2020. The pandemic turned it into a crisis. All right, so map the areas due to geocode by zip code can be accomplished with the zip code R package. I think I've used that package before. It's really helpful. And yeah, so let's load in the data. Generally, I start with the Tidy Tuesday R use tidy template for today. All right, and I like to just I like to add library scales, theme set, theme light. Run this and load in today's data. Take a look at the README. So we're looking at two data sets, one on broadband and one on broadband by zip code. Okay, then this is by count. Is that over time or no? It's by state, county, county name, percent of people per county with access to fixed terrestrial broadband at the end of 2017, and percent of people per county that use the internet broadband speeds. Some methodology described above. Oh, I guess that's this methodology. Okay, and this is the link to it, sounds like. Okay, I'm going to start just with broadband, and let's take a look at what columns we have. All right, well, one thing is I probably want to clean the names, so I'll use janitor, clean names, turn those into snake case. Looks pretty good. I'm going to rename, because it's my data set, I'm going to rename state to ST. ST to state. Feel good about that. Okay, I'm going to call this broadband. And I'm going to do the zip by zip code. So TT broadband zip. Looks like it has, I'm going to need to clean the names again. Turn them into snake case. I'm going to do the same thing, rename state as ST. And this looks pretty good already, just like error range 95%. So cool how clean names is able to turn that into 95% into 95%. Yeah, and let's take a quick look at this. So we're definitely gonna be making a map today because we've got this this MSD. It's mean signed deviation. So an estimated bias introduced by the process. I'm not familiar with mean signed deviation. I'm more familiar with like standard deviation and such. That's maybe I need to look this up. Now, error range, MAE, yep, all right, so the so MAE I'm familiar with, which is the average absolute error. Let's dig into those errors in a bit. I think they're going to be important and interesting. But first, let's see. So it sounds like this is by county, this is by zip code, which is considerably more specific than county. So it breaks it down. Yeah, but let's actually start with county. So I'm actually going to call this broadband county. Makes it easier for me to remember what it is. And then this broadband zip and get rid of the view. And let's start with broadband county. So what I'm going to do is arrange, I need some population data by county, and I've seen this data before. I can't remember where I could find it. The census data maybe? Yeah, I think I can get it from a census package. So Tigris, take a quick look, is shapefiles. That's cool for counties, but I really want, I'm going to want, let's see, R package US counties. I know I'm going to join in some data that's something like population. I really just, let's see, county census. Tidy Census, that was the name of the package. Have I used it? I think I've used it before. And let's take a look what the I mean, what is the key functions here? I think it's feature data and feature geometry for the ACS. I'm just trying to remember what the some of these are. For the decennial census. Let's start with the. I think the ACS has the Yeah, let me take a look at this. I think it's been a while since I've used this, so I'm kind of reminding myself how it works. Uh, all right. Ooh, I need a key. Man, this is always this isn't this always the thing. This is always the thing. What about get decennial? See, this is the problem is that yeah, I have a key. Sorry, I'm thinking for a second about how to handle this. I have a key for this, and I don't want to access it and find it and work. I don't remember where it is for one thing, but I don't want to find it and work with it while I'm literally screencasting. Is there a thing I can do that would stop that? I haven't even the first idea. Can I click a button that says I can stop streaming? Does that kill this? I'm gonna try. I could try stop streaming. Let me come back to that in a second and just ask, can I get U.S. population by county? And I just want to know, is this remotely readable into R? Yeah, this could be read into R. Not trivially, I'm going to need to skip the first 3 rows, but I think that, yeah, I'm going to try this out. So what I'm going to do is I'm going to skip tidy census for a second and read CSV downloads, what was it called? And when I said read CSV, I of course meant read Excel. And that comes from read Excel, the read Excel package. Here it is. And skip equals, yeah, I think if I do skip equals 3, let's try this out. There we go. And yeah, so skip, all right, so this is getting, I'm already getting a lot closer because this shows like per year. And now I'll start with county equals, so I put up the Rio package, and thanks Madche, and if I haven't used Rio in forever, if I do Rio import, let's see how this looks. Man, it's not a tibble. Nah, it doesn't. It ends up pretty similar. I'm gonna keep the keep my read Excel. Cool. And but thanks. Yeah. So if I do county and oh no, not this is dot. What is it? Clean this up a little bit. Dot 1. Of course. And I also want to grab county and what is the second column? Census. Well, I probably want to go with, say, the 2017 population because it looks like that's where what we're working from. So I'm going to say population 2017 is 2017. This is the 2010 census. I'm going to use the population estimate as of 2017 because that's what we're looking for in the Excel. So I'll say county population. Okay, it's a start. Here we go, the county population, and now I can finally join that in. Woohoo! I just think I can use the zip code. Zip code is probably even a little easier. But let's do county population by county. See, they have both the county name and the state, so I actually needed one more step. I need to separate county into county and state, and SEP is and United States did not quite work. Also, why do I have a dot at the start? Look at those dots right there. Mutate county equals string replace, string remove, county starting with an escape dot. And okay, this looks like I might be able to join it with counties, and it's county name. I'm gonna call it county name. Here we go. So actually, let me make that a left join to see if I'm missing any. And I'm going to remove the state, just for kicks. Oh wait, no, I probably need to join on both of them because it could be the same county, multiple states. I don't know if that happens, but in case it does, I'll join by, and one of them is one of them is short and one of them is long. So here's what I do is I say, take these states, and I'm actually going to do mutate state equals, check this out, there's actually, I think I've used this before, there's state.abbreviation and state.name just built in as vectors in R. How about that? So I can do something like state is state.name match state to state.abbreviation. And now I've got this. Does it have an NA? Yeah, it probably has DC in there. I'm going to ignore it for the moment, but that's a fair point. And then if I try left join on both county name and state, filter is NA, population 2017. Very few that are missing. That's good. Very few that I wasn't able to line up. One was DC. Yeah, why don't I go, I'll go ahead and fix that. I'll say state is if else, state is an A. Fix it up, and otherwise state. And then if I do, let's take a look at the ones that didn't match. That looks good, and not is in a population 2017 is what I'm saying. Is in a, yeah, these are the only ones four that are missing. Whew. All right, so the and I don't know what they are, why they're missing, but I'm not too worried about it. All right, so the just to check, is that right? That, yep, Broadband County, and then, all right, so I'm gonna make it an inner join, and I'm gonna arrange descending population 2017. Where was that in the README? I'm seeing it was so this was 2017, this was 2019. Sure. Broadband availability. Percent of people per county with access to fixed terrestrial broadband. Okay, so the reason I was interested in that is that it's hard to look at anything like usage if you don't have some measure of availability or usage really, if you don't have some measure of population. So the most populated counties in New York, pardon me, in the country include like LA County, Cook County, that's where Chicago is. Harris County, I think that's where Houston is. Maricopa, I think is where Phoenix is, and so on. And going into Kings, that's like Brooklyn, in my understanding. And we can say, okay, in these populated counties, the availability is pretty high. Let's actually take a look at that. Let's say arrange descending population and broadband with population. And let's do county name, and let's start with this county name by population. I've got a few thoughts on how I'm going to clean this up. And let's do a, yeah, here's what let's do. Let's say county is a combination of paste string remove from county name, remove county from the end, and comma, and then state. And let's use paste 0 to state. And then let's throw in a second step where I say county is FCP reorder county by population. And we use this on the y-axis. Okay. So I can say in our largest counties, well, this is actually not that helpful. What I really want to know is broadband availability. And this availability per FCC. So let's take a look at our 25 largest. And why am I putting, so I meant to do this. And I meant to flip these two. What I meant to do is, oh, the problem is that broadband availability per FCC is not numeric. So let's fix that. What I need to do is say broadband availability is two things. One is I'm gonna, I like that it's between 0 and 1, but I'm gonna have to do parse number from readr broadband availability per FCC. And yeah, it looks like there's some things that didn't pop up correctly, and what I see is I've got these like dashes. Those just need to become NAs. So that was the reason it wasn't quite reading it correctly. In fact, no, yeah, it's fine. This thought in terms of this could have been cleaned. I'm gonna put this here, okay, and do the same thing for broadband usage. Here we go. Now I can represent these, and look at me, still not work. Oh, because I need to redo this join, and then I can redo this. Here we go. Instead of a geom call, which is not useful when everything's close to 100%, we probably want it more like this. And now I can throw in a scale x continuous labels equals percent format, and let's make it the top 40 counties. So this is about, it's not, I think, not that helpful. This is asking, like, of the most populated counties, where how much broadband availability do they have? It's not really like, it's not, it's fine. It shows that of the top 25 most populated counties, only a few, only Harris, Texas, San Bernardino, California, and Maricopa have below 95% broadband availability. Excuse me. But the but that's not like, it's not like that insightful. I think I might want to try a different one where I say let's keep yeah, let me actually keep I've got county name. I keep county name, but I'm also going to keep county in there as like the combined name that I really want to work with. Still using county name here so I can do the joining and everything. And here we go. Okay, I think I want to do this plot where the x-axis represents the total population and the y-axis the availability. I find that useful because the between 2017, and I'm always do this with a scale x log 10 and probably the top 100 rather than the top, say, 20. And the source I want to say what are populated what are high population counties that have relatively low broadband? Had the top 100 counties didn't seem to have a lot that were low. Top 200 counties a bit more. So what I'm going to do is I'm going to add in a geom text as label equals percent. Label equals county. And I'm going to do check. Yeah, I'm going to do check overlap equals true. And v_1, h_1, because I want to show which are these countries, and I'm going to need to do population 2017 is greater than or equal to, what is that, 30,000, and I'm going to need to say expand it out a little bit so I can read. Here we go, it's a little better, and make it 10,000. Here we go, I'm able to read most of these. It's not a perfect graph, but we can kind of see, like, okay, now Arizona. Place in Arizona kind of looks like Texas, Arizona. These are generally the places with lower broadband availability. All right, I'm going to quickly add y is broadband availability in 2017, population in 2017. And I'm going to do a few other things. Labels equals comma format. Looks a little better. Still like not gaining a ton out of all these crowded ones up on top, as you might be able to tell. But yeah, so you can see like Navajo, Arizona, Pinell, Arizona. Okay, so so we're seeing a couple that are like a bit bigger and then also like relatively low broadband access. All right, let's look at the second column we've got there, which is the broadband usage. I'm going to start with the same exact graph, but with broadband usage on the y-axis. And now that I think about it, broadband usage is in 2019. Let's bring in the 2019 population. I don't need this. I can do that by saying here, 2019, not that it matters a huge amount, but it's just nice to make sure that we're using the same definition. And now I've got a population 2019 column. And here we go. All right. And now we can see, okay, of the most, what I think is interesting about this is that while generally there's really, there's still a positive correlation here. I'm going to try, we're not going to be able to read some of these, but I'm still going to leave in the dots. It's just the best we can do. And let's throw in a geom smooth. I'm just noticing that the higher population of a county, the more likely, the higher the broadband usage tends to be. But it's not absolute. Cook County is not that high. Santa Clara is very high, etc. Okay, and to just remind ourselves, it's percent of people that use the internet at broadband speeds, the speeds of 25 megabytes per second, or 3. I don't know. Oh, and this is, I think, a download and upload or something like that. Yes. But all right, so then use the internet at these broadband speeds. That just something that's interesting is the size of it. The generally bigger more populated counties are more likely to use. I think that kind of correlates to like city and country, but we can probably find other combinations that would confirm that. Okay, so that's some thoughts in terms of by county. Let's start looking by zip code, especially so that we can. I'm sure we're at some point in this process going to. Here we go. I'm sure at some point in this process we're going to use to make maps. Good. This one gets the broadband usage. Percent of people, this is per county, I think it means per zip. Data's from 2020, so I'm going to throw 2020 into our, here we go. Population 2020. Yes, we could tie the data. I don't think it actually makes a huge difference here. But the 2020, here we go. Oh, nope, don't have 2020. Have to use 2019. That's all right. In the data set that I downloaded. And all right, so we have zip code and we have. Do I want to do the same thing to county name? Yeah, I kind of do. I could kind of pull this out into some functions, but I want to grab out. Don't want to do the reordering. The main thing I want to do is, okay, I've got my postal codes. Okay, we got 32,000 postal codes now, not just these counties. So we're going to be doing some stuff. We're certainly going to be doing a map, but first I want to bring in some zip code data. I found a great package recently. I don't know who's credited to, but maybe someone can actually can I share because I think code R. So I found a great package. It doesn't have any package docs, but yeah, zip code R brings in some data that here we go, zip code. This like zip code DB. Reminding myself for a moment, is it a data frame? All right, as tibble of zip code DB, we get this combination of like zip code type, major city. So like we can bring in city instead of just like zip code and county, and we can do all these other things like bring in our population and population density and land area and water area and number of housing units. I'm really excited about this. There's so much more we can do with this than now we're not quite. We will have to work a little hard to make it a map, but this we can bring in a lot of interesting zip code level data. Now, Jim points out that we have to fix the zip codes, and yeah, we have to fix the zip codes on one of these two sides if we're going to join them. So the let's take a look at the let's show how to do that. So we've got this column, it's numeric of postal code, and we actually want to turn a number, like if we had a number, I used to live in Cambridge 021138. Problem was I want that to appear as quote 021138, and let's see if I remember how to do that. There's a function called sprintf that formats a number, so I can say, okay, format this number, but I think I can say leading zeros in this formatting string. How do I do, shoot, how do I do fixed width? Let's see. There's fixed width number. There is a, here it is. Percent zero, that's the one. Okay, this is the thing I was trying to remember, is sprintf percent 05d. So if I do, here we go, postal code, sprintf postal code, and before that I do percent 05d, that's what it was called, a formatting string. Then there we have it, and I can filter for postal code is 02138 and find, yep, Middlesex, Massachusetts, and yep, so I can do, now I can do any joining that I want to do. So the so what I can do is I can take my my broadband zip and I can interjoin it with zip code DB by what is it called in zip code DB? It's called down here, zip code. So I'll do by postal code equals zip code and state, I guess. Am I going to lose any? Nope. Yep, I'm going to lose lots of them. I am going to remove state. I don't want to use the state in the on the right side. I'm just going to keep everything else. Okay, and I'm going to remove county. It's just I don't want to bring in state or county. I want to trust the ones that I already have, because why not? Yeah, now I can actually say, just taking a quick look at this. Yeah, now I can look at something like a range descending population if I want, and say, okay, this is the zip code with the highest population, and here's the broadband usage. Really going to want to work with a bit more. I'm going to want to say something like, let's broadband with population zip joined, I'm going to call it, and let's bring in a little bit on population. Let's earlier I had this theory that the county population was actually about the density. I've got population density. If I go to zip code DB's documentation, I think I'm going to see, here it is, population, persons per square mile. So I can show, okay, population density by broadband usage. And I'm going to need scale x log 10, otherwise it's not going to be very informative. I also might want to say population must be greater than, I don't know, 100 at least. Heck, let's make it 1,000. Let's say of zip codes with more than 1,000 people. What's the relationship between population density and broadband usage? All right, so in general, I think they're, let me make it 10,000, just so crowded right now. Okay, already I'm seeing, one thing I'm actually seeing here is, so many have 100% broadband usage, okay? And I'm actually seeing kind of two clusters, which I didn't really expect. It's looking like there's low population density, low broadband usage. And then there's kind of this and then generally kind of as population density increases, this increases. And then there's this other cluster that has like higher population density, which I should specify as an people per square mile. I'm just cleaning this up a little bit. And let me throw in a smoothing curve. I do wonder, is there even I kind of have this theory that it would be correlated. I'm not, yeah, I mean, also if I force it to be linear, yes, correlated. I wonder if I allow it low s as a way to say, like, to add a curve that isn't necessarily a straight line. Maybe it kind of levels off at the top. That's a little bit interesting, though it's hard to tell because it gets very, there aren't a lot of zip codes that are this high or this low. All right, so I'm going to leave in this, even though it's not perfect, I'm going to leave in the generally positive trend. Okay, I wonder if there's some kind of regional difference here. I wonder if, say, this is in some areas like this is people per square mile in zip code. Clear. I wonder if it's some kind of regional thing. So what I'm going to do to quickly test that is filter for a couple states. I'm going to some of the biggest states we have, and let me quickly check what are the states with the most zip code. It's not exactly the same as biggest states, but Pennsylvania is a good one. And I'm going to color by, I can facet, but I can also color by state. And if I do color by state, I probably want the line to be so. You know what? I take it back. I am going to facet by state. Yeah, this helps a little bit give a sense that there is some regional effect. Where it's like, okay, New York has generally more populated zip codes. California less so, and California like less so. And there's kind of but there is this double clustering kind of effect in California that makes me think it's like, I wonder is population density bimodal? This is an interesting question. Is if I took this and I said, what's the density of population density? What's the histogram of this, scale x log 10. It's a little bit bimodal. All right. So it's I really wanted to take a look at some of these, and that is pretty curious. All right, pretty interesting. But I'm going to want to use Tigris because I'm going to want to make some maps. Do I have Tigris? Yep, seem to. And library Tigris. And let's see if I remember how to. I don't remember how to use it. Let me see if we can get it. Tigris. Can I get a shapefile for the entire country? Is that going to be insane? Yeah, I'm suddenly a little nervous. Okay, I bet we can't do. I just changed my mind. I don't want to do zip code level. I think it's going to be a very crowded graph. So I'm going to go ahead and do county shapefile. I'm getting this idea again. I'm getting this idea from the here help with census shapefiles. Ooh, here it is. Map the area. You'll likely the geocode by zip code. Zip code R. Where is the geocode? See, I see the bounds. I don't. Where's the shapefiles? That's what I'm wondering. Do I have zip code shapefiles? Do I have the shapes for every single zip code in the zip code R package? No, see, I don't see it. Maybe Tigris can help me get it internationally. Let's see. I wonder if nations, divisions, states, counties, tracts. Where is I just saw this, Tigris zip code. I changed my mind back again. Maybe I do want this one. ZC TAS. I know I'm a little, let's see. Defaults to null, return all ZCTAs in the US. All right, I wonder how long that'll take. Year equals 2019. So yeah. Error, cannot open this. CEST drivers. And I try turn on caching, though I don't think it's going to make any difference. Well, I definitely have the internet. Can I grab any of them? Okay, I can grab some of them, but not others. Maybe there's something, maybe something's not working here. What does this look like if I grab just this one? Oh man, this is like, yep, just the organized area. All right, I wonder if I did like, starts with, I really do wonder, this is a little silly, but what if I did like, oh, well, first of all, I'm wondering, did I do it, did I successfully cache? Yes, I did. All right, so I'm going to try doing this. Starts with 0. I'm wondering if I'm just able to say starts with 0, starts with 1, starts with 2, starts with 3, and so on, and then I'm able to use, I'm just able to join it with that. Wouldn't that be something? What's funny is maybe I can run this in a different window while we continue on another path. Because it's doing caching, I have a vague suspicion. So I'm going to open up just like a random R session. Tigress. This is a little trick, and I'll use the cache. And now I wonder if I download it in one, is it going to be able to use the cache in another? Well, let's find out. If I do this, yeah, it's able to share the cache across them, which makes sense. So and then I'm probably able to do this. This is still, you know what? I bet this is not. I decide I'm going to do it anyway, but I'm probably not going to end up using it just because I have a feeling these shapefiles are going to be way too big. Workaround, 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 workaround. Got to see. I'm just going to load in all these in the background while we're this is not right. I don't know why that was fast. I don't think that should have been fast. But let's try counties. I really haven't done US level county. I've done a lot of state chloropleths. You've seen some of them in these ones. But I haven't really done county level ones or zip code level ones. That's a lot of shapes. I wonder, did this work? Maybe by doing starts with 0, it somehow downloaded all of them. And I see GeoID 10. Huh. Okay, this might actually work. What if I did this and I only took the top 20 and I tried plotting them? What is that, GeoMSF? Man, that sometimes means I just need to give it a palette cleanser or something like that. GMSF is, I think, supposed to be how you plot these shapefiles. Gosh, it isn't. Well, there you have it. I'm able to plot just a couple of them. Given how long that took, I'm going to go ahead and not use zip codes yet, and let's figure out some way to do kind of sampling to a lower resolution. But I'm going to go back to that counties one. Whew, all right, let's take the counties and say, what if I did head 20? What if I tried plotting the top 20 counties? Oops. When I say top 20, I don't actually mean top 20. Take 100. Oof, this is slow. That is true. Hey, does somebody remember, there was a previous one where I said I want to sample down our shapefile sample resolution. I want to reduce the resolution in a way that yeah, it's something like simplify. Simplify, is that the one? Does anybody remember this? It was a previous. Oh, what am I doing? I've got a I've actually got the R project open. Let me try search. Oh, this is slow. Save. Is this running? Is this? Do I have anything? Is anything running at all? Something's running slow in the background or something. Maybe it just doesn't like all these objects I've got open. All right, so let me try this one more time. Search. Simplify. There it is. ST simplify, D tolerance. Okay, let's try this out. And that's in SF. Okay. So the SF. If I take counties, do I need can I ST simplify it? No. Nope. SF, what was that other one called? SF, STSSF? Nope, that was not that looks like it was already, that didn't seem to matter. So if I take this and I do head 200, shame about the longitude latitude, I'm going to just assume that it's no big deal. And now if I try plotting it, so again, all that happened is I remember that at some previous point we did this. Oh, nuts. Nuts, nuts, nuts. I was all excited about this. Weren't you excited? I was excited. See, I did this in some previous one where I said, take your Kenya counties and simplify them, and it just worked. What was the difference between these two data points? In this one, doesn't correctly simplify longitude, latitude. Do tolerance this be a decimal? All right, that might have been closer. Okay. And now if I do 200, I think yes. All right, so I think the story is I need to change the D-tolerance in this threshold. Oh, okay. Getting closer. How big is counties? How many features? How many are there? 4269. Okay. Then all right, and I'm going to want to filter down out. I'm going to want to filter just for the contiguous United States. So I'm going to say counties. But yeah, this is the point is we're getting a lot closer here than we were before. So this is good. This is a good sign. I'm going to join in. Yeah, what I'm going to do is I'm going to take my broadband with population. That's by county. And I'm going to look at county ID. See, 1001. I wonder if I just did name by name LSAD. This might be, I'm trying to figure out the right way to, so these are like all IDs and trying to figure out the right way to join it. And I'm going to try joining it by county, so join with county, with counties, I'm going to call this counties SF, like not San Francisco, but rather counties map, county shapefile, and joined by county name is this. And now, why did it get? Why is it bigger than the county's SF? That's why, because there's Washington counties all over the place. Can't go quite with that approach. I'm going to need to go with the county ID. So then I think that county ID, I think that this is the same as, check this out. I'm going off like old remembered things. I think it's a little like a zip code where it's always going to be the same width. So I do not think any of them is going to have, counties and stuff. I don't, yep, but maybe one has 0, and that's the one. Outaga County, which was, yep, those two line up. So basically we do the exact same thing we did to the zip code. That's sprintdef I did earlier. In fact, I'm going to do it all the way up here. We're going to say county ID is this on county ID. It's basically like a zip code. Yeah, I've seen these at county IDs before. They're not nearly as like famous as zip codes, but it's not the first time I've come across them. I think that they have a name that's something like FIPS, I think. And I'm going to rerun, tripping all over the place. Again, this is really new to me, this kind of approach. I'm going to rerun the population join, and then I'm going to join it. Nope. But instead of this, I'm going to do by county ID equals GeoID was the name of it. Nope, not county ID. Let me see. County ID is right. GeoID is right. Oh, look at that. I spelled it country ID. Huh. Yeah, I think that join actually worked, because before the join I lost one that could have been 1,000 different things, but this is pretty clear. Thanks, yes, thanks, Eric. I know we're on the chat's coming to me on a delay, so I just saw that useful fix. But yeah, now I'm going to ggplot geomsf. The trouble is this, when I did the join in this direction, I think it became a tibble, and I actually wanted it in a different form. I think I actually wanted to do it in the opposite direction. And then it knows how to, if I do the counties SF join to the Broadband, oh, I forgot to do the sampling. Oh, I forgot to do the simplification. Oh, I do not know. This is going to crash. I think this is going to crash everything. I have a solid bet that this is going to crash. I'm going to go and sure, let's turn radar if it works. What I'm going to do is I'm restarting our studio. It's okay, I copied the file at the last second to make sure I didn't lose anything. And I just run a couple of these steps again. Not using these anymore, just let me get caught back up. Good. And use the cache. And you know what? I'm going to sample it early on so that I can't forget about it. st simplify, the tolerance is 0.1, and I'm probably going to be turning that down at some point if it could end up. Let's see. All right, so that's counties SF. Okay. Whew. Here we go. Now we're a lot closer. The problem is there's something up here. I think it's a bit of Alaska that ends up like outside this boundary box. So I'm just gonna throw in. I've got state in here. Filter not state in Alaska or Hawaii. we're bringing that state earlier on, and that's just going to make this a lot easier. Here we go. Now we're cooking with gas, and I'm going to bring in a couple of things. I'm going to say library GG themes. You know we like chloropleths here in Battalion Tuesday whenever we have this kind of data. And I've never actually made a county level chloropleth, so I'm interested in this. And so I'm going to add theme map, and I'll add coord map, which comes with ggplot too. So look, I've got a little hole in the middle of the. It didn't line up. Sorry. So coord geom_sf expects coord sf. I think I don't know the difference. I think it's still a projection, but yeah. Well, look at that. We got one missing, and really noticing that one that's missing. I'm noticing so much. I'm gonna left join it, and nope, hate that because I need to. Nope, didn't like any of what happened right there. I think there was some that's including things like Guam. I'll just leave this in, and yeah. Now let's. But yeah, what was the reason we did all this? It was so that we could add fill equals broadband. Is the broadband accessing is take this broadband with population and say broadband availability per FCC. Throw in a scale fill continuous labels equals %. And I'm doing continuous, but it's not going to be a good fill. I'm going to do a gradient 2 and say low is red, high is blue for not enough internet or plenty of internet. And the midpoint is 0.5. I don't know for sure the midpoint is 0.5, but I think it actually wasn't far off from that. And man, yeah, now you really can see this like I'm doing availability. I actually think I want to do broadband usage, which is, yeah, it's just broadband usage. All right, and was I right about that? What was the distribution of broadband usage? Let's actually take a look at that. This thing I should have done earlier. Broadband usage. Let me do it on this data set. Oops, histogram. Yeah, so I was wrong to set a midpoint of 0.5. Looks like a lot of counties that are in the 0.1 to 0.25 range. Whenever it's in a midpoint, it's nice to set a median. So we say broadband usage and 0.24. I'll leave it as 0.25. It's a nice round number. And this says, okay, here we go. And here's, I think, a pretty useful visualization. I also realized the thickness of these is too high. Do I remember how to reduce the thickness of the edges? Something like, yep. Motor, that's exactly the thing I was about to do, is the lines were too wide. 0.1, I'm going to make it even a little thinner. That's pretty good. And let's add something else to say labs. Fill is broadband usage percentage. Yeah, so what are we kind of seeing here? There's no question there's some centered around cities, but we did see, okay, so we did see though that it wasn't as simple as, I think, let's go back to that graph. Well, problem whenever you have chloropleths is that sometimes they just represent population. Here there's definitely truth to that. It definitely is correlated with population. But let's take another look at that population visualization. We can say, was this the one? Population by broadband usage. Yeah, I think that is a lot of it's a lot of what's happening here, but there really is a lot of variation there as well. So it's like, yeah, some areas like Cook are really high, and what happens if I include the counties that have very few people? Oh, that's not the right way to do that. You know, there is a pretty strong correlation where it's like when you're higher than a large certain amount, your population is larger than a certain amount, you're almost certain to have you're much more likely to have higher broadband usage. So part of this is just urban versus rural. So if I do this visualization, and I think I saw a similar one in the Tidy Tuesday. I think this looks like it says, all right, less than 15%, greater than 15%. So this was particularly highlighting like what regions have low broadband, and again, it probably would be somewhat. So it's like here would be below 15% would be if I drew this. If I'm drawing this one, if I'm drawing this one, it would be something like geom h line. And I meant to do y-intercept. Here we go. So this was like broadband usage and population. And the question that was being asked in this graph, this chloropleth, was what percentage, what fell below 15%. It's fairly useful because you can tell, like, okay, the ones that fall below 50% tend to be smaller counties, but really not all of them. And yeah, we can. I can duplicate that when I can pick some threshold, and that would look like this. We would say fill is broadband usage greater than or equal to 0.15, and we do. Yep. Oh man, look at those gaps. That looks less than fantastic. But it's because of that sampling that I did. Let me make the sampling a little bit more precise, and hopefully it won't get too slow. But I'm not going to keep this just because there's no reason to. I think you can see it looks a lot nice that way. So this, and if I did this, I would probably do something like they did in this graph, where it would say something like scale fill manual, and then values equals gray and red or something. I think they use something. They use gray and blue. I kind of like gray and red to say for red to be like this area is in trouble, and I got that order wrong. Because greater than 15, false should become red, true becomes gray, and we can. This is like the variation of that plot. So that's I think another alternative. But so I'm gonna. This is similar, yeah. Copying the map from. I'm gonna call it reproducing the map from The Verge. And yeah, if we do this like this scope of something interesting is we could ask about population, about what would it look like if we just used population is I think a reasonable question. So we could start just by saying do this on a log scale, trans is log, and I'm not 100% sure how to do this. Fill is population 2019. We would say, what would it look like if we just looked at population? And that trans log did not translate well at all. Midpoint. Log. See, I'm doing the wrong thing when it comes. I can't figure out what the right midpoint is on this log scale. It's something like. See, it's somewhere. What is it? It's. If I want it to be 10,000, it would be 9. All right. The problem is the midpoint is on a log scale. So woo. Yeah. So this would be just like population, a variation that just looks at population. And I say, great. Let's make it log 10, and let's make that 3 to be 1,000. That makes it simpler. Or 4. Yeah. That's like if we just did population, we'd find something like this. But again, it's not exactly lined up to population. I'm putting this in appendix. We're not going to spend much time. We're not going to spend any further time on it. But yeah, I just want to note that. All right, so this is a graph of like a broadband usage. And we really no, this is not. This is our chloropleth of broadband usage. And yeah, we really can see there's some areas that use really, and it is like, it has a correlation population, but it's not exactly the same, and that lines up with the plots that we've been making earlier. And yeah, it would be interesting to link this to other things besides just rural urban population density. It'd be interesting to link it to, certainly to things like the average income or things, or that kind of information. But yeah, I just wanted yeah, well, it's really cool that we had to set up like a graph like this based on a map like this based on counties. Question from I don't know if it's maybe Moche or Mocha. Divergence color scale should have a zero for the white area. I actually disagree with that because if we did a zero white color scale here, we'd never be able to show the negative values. So being able to have, I like putting white as being the median in the sense that you can be good, you can be bad, or you can be the median. I prefer it a little bit when it's something more like a normal distribution, which this is not. We actually saw this as a histogram. But yeah, I generally don't follow the principle that the that zero should be the white on a diverging color scale. If that were true, we couldn't make a graph like this. All right, so this was a really, but I appreciate the point. It's well taken. So what do we do today? We did a lot of data. We did a solid amount of data cleaning, just some number parsing, some matching of states. We worked with geography a bunch today. We looked at zip codes. Then we did a little bit of exploration. It helped inform us later. We tried answering some questions about the relationship between population and broadband availability and usage. In particular, I think it was important to show, like, if we look at the areas with low broadband usage, they are correlated with lower population counties, but they are definitely not the same. And that kind of helped inform our later analyses. We brought in some zip code data with the fantastic zip code R package, which has this table that I was able to bring in things like population density, land area, all these other pieces of information. I didn't rerun this. And, oh, right, yes, I restarted R and didn't rerun this. Oh, here it is. I didn't look at median household income. Let's do one more graph because I think it's so cool. Let's ask the question about, so it's the same question we do above about population density, but let's actually quickly ask it where we say filter population. It's greater than, let's say, for zip codes of more than 10,000 people, how does median household income correlate with, I just really want to find this out because I'm curious, with how does it correlate with broadband usage? And I'm missing some things. I need scale x log 10, and I meant to use this. Here we go. Log scale, interestingly, not likely correlated, not as much as I thought. Yep, it's looking like kind of like you're like, okay, what if I filtered only for really large zip codes? Does that change anything? No, that's too large. No, not that correlated. I could say, yeah. So that's actually, I think, something kind of interesting. I was kind of assuming that this would be somewhat scaled to income, but throw in a best fit line, huh? All right. Positive correlation, but it's not like so apparent. All right, and it's also tough because so many things are at 100%. All right, what do we do next? Thanks for bearing with me. We brought in the counties data using the Tigris package. Did some simplifying on it so that it can be plotted on a large graph. We joined that together. It took a lot of effort to get to this step, but we joined those together based on their GeoID. Forgot to mention that we had that great sprintdef trick for turning a zip code or a GeoID into 5 digits padded with zeros. That's sprintdef is a useful formatting function in R and other languages. And the we use it to get a chloropleth that looks like this, where we show the percentage of broadband usage. So yep, that was really fun. I learned a ton because I don't know if I've ever used Tigris before, and getting to bring in that shape data was pretty handy. And any chance to use zip code DB is really helpful. It's just incredible how useful it is to bring in that kind of data by zip code. So many data sets come with that. No animations today because we don't have graphs over time, and but yeah, this was our end result. Thanks so much for joining. If you had fun, please do make sure to like and subscribe, and I'll see you next week.